and in the Office of Graduate Admissions. And we have a professor from the Mechanical Engineering Department and a current student with us to discuss the format of the program and what it's like to be enrolled in the program. After the review and student perspective, we will discuss the admissions process. Before we let's go issues. Please, if you have questions, please send them in the Q&A chat window. Staff will be moderating the chat window, and we will have a Q&A opportunity after action. If you have general or personal and specific questions, they can certainly be emailed directly to our office, and we'll be sure to answer them as soon as possible. Professor Zenyuk in the Department of Mechanical Engineering telling us about herself, her research, her background, and what the academic goal of the degree program is. Professor?
My name is Iryna Zenyuk. I've been a professor in mechanical engineering at Tufts University for 2 years. My background is and research interests are in electrochemical energy and convenient storage. So the research on devices such as fuel cells, electrolyzers, batteries, and then involve the fundamentals that we learn in mechanical engineering, such as thermodynamics, fluid mechanics, renewable energy. I got my degrees in mechanical engineering from Carnegie Mellon University, and I got my postdoctoral degree at Lawrence Berkeley National Laboratory. So currently my group has about 6 PhD students and 2 master's degree students. So the degree programs that we will overview in later slides, I would like to mention it requires rigorous academic background. Tufts graduate students are highly motivated. Some of them are very project-oriented, and those are the ones that like to do master's degree thesis track, and those that are more interested in learning in depth fundamentals take more of a 1-year course-based track of a master's degree. That we will overview in later slides.
Okay, and Professor, can you discuss a little bit about the program, the courses that you teach?
Yeah, since joining Tufts, I've taught undergraduate course in thermodynamics, and I've also taught graduate level mathematics course, which is called Applied Mathematics. And this course serves as the fundamentals in mathematics and can be applied to all the other graduate level courses. So we learn how to solve partial differential equations with various techniques and using various also computational software. And I also introduced the course on electrochemical energy conversion and storage, and that's a graduate level elective course. So in this course, we learn what are the thermodynamic kinetic limitations of current state-of-the-art technologies in energy sector, such as, for example, batteries, supercapacitors, fuel cells, grid-level energy storage, and also common topics, also some solar energy. And we combine both fundamentals, and through the project, we also use quite applied approaches too.
Why ask Professor Zenyuk to discuss the program format of the MS? 2 separate program formats, one with thesis and one without thesis. Professor, can you discuss the differences and what exactly is the goal of each program for people that are enrolled?
So, computer science with thesis offer it in mechanical engineering or in human factors. So those are two different programs, and the students can apply to either of those. So the coursework is about 8 classes, and they're divided, or some classes divided between 5 core technical classes and 3 graduate electives. So for technical classes, we generally emphasize choosing 2 core sequences. So the student has to focus on 2 areas of interest, and there's 4 available currently. So 1, controls and dynamics. 2 is solid mechanics and materials processing. 3 is fluid dynamics and heat transfer, and this is my area of expertise. 4 is inventive design and advanced product design. The student usually chooses 2 tracks and pursues 4 classes in this core technical classes. And then 1 applied mathematics class, and then the 2 graduate electives gives more of a breadth to the program. The program culminates in the 3-credit thesis. So students should select advisor at sometimes at the beginning of the enrollment. So it's a 2-year program. Once the student gets integrated into the research group, learn the most theoretical laboratory work depends on the research interests of the student and advisor. And by the end of the program, by the end of the 2nd year, the student writes a thesis. And this thesis will also be defended in a public setting with about 3 examiners, and also can be published as a thesis and also as perhaps a journal publication. Full time is approximately 2 years. Master's Science without thesis, it's a generally 1-year program, and as you can guess from the title, it does not require thesis, so it's mostly course-based work. So the courses know about 10 classes. And once you choose 2 core sequences and take 4 classes from that, applied mathematics, and then we have professional development, which constitutes 3 classes. And this professional development classes helps students to improve their technical communications, such as business communications, for example, or analyzing big data, data acquisition, which involves development of report writings, presentation skills, etc. And also, we also emphasize professional development in this Masters of Science without thesis track, where a student can take credits from South Gordon Institute, which has a wide selection of various professional development courses and electives. Furthermore, both of these programs involve enrollment into the seminar. Generally, we have weekly speakers from the United States institutions and those abroad that deliver seminars on various research topics, and students are expected to attend 80% of those seminars. And this ensures that the student also has this breadth of understanding of the research projects that are out there in academia and industry.
And you mentioned professional development for those that are enrolled in the program without thesis. Are the students that are enrolled in the program with the thesis eligible or allowed to attend the seminars? Do they receive professional development as well?
Absolutely, the students can enroll in those extra classes, to my understanding that they are not required for they are not required for the degree, but they can take them as additional courses to their degree. And that's yes, that can be done by any master student with thesis or without thesis. So I covered master's degree in mechanical engineering, and I'll have the master's degree in human factors with thesis or without thesis. So the requirements are quite similar. And the director of the program in Master's Science Human Factors is also on the phone. So if students can have questions about this program, I can direct them to James, Interrogator. So quite similar, but our classes vary. Now students take human factor core classes instead of classes that I mentioned in 4 tracks of mechanical engineering. So human track, we have for non-thesis option, we have core work is about 10 classes. We have human factors core classes, then a core design class, some 2 analytical classes, and professional development classes. There are 3 classes. So it's a little bit different program. The emphasis is more on the human interaction with, let's say, with machines, mechanical engineering devices, and that's strong emphasis on design.
Professor, can you discuss how a person in the program can do interdisciplinary work with possibly another department that's related to their interests?
That's a great question. So we have 2. So for example, for the thesis track, we have 2 elective courses, 100 level. So it's a general graduate level courses the student can take in engineering, science, or mathematics. In consultation with the advisor, the student can choose those electives to be of specific interest to the student, so they can be easily from, for example, chemical engineering or physics or chemistry, or as long as they fall into the category of engineering, science, or mathematics. So, for example, in my research group, the research is very interdisciplinary, so the students are taking courses from civil engineering and chemical engineering to learn those fundamentals to apply to the type of research projects they are working on. So it's quite flexible program, and we allow give the students possibility to pursue their interests.
We just want to remind our participants, if you have any questions, please feel free to type them into the Q&A chat box, and we'll try to answer them as promptly as possible. So now I'm going to talk with our current student who is on the call with us. Stanley, could you please introduce yourself and tell us a little bit about your background?
My name is Stanley Normile. I'm a MS PhD candidate in Professor Zenyuk's research group. I actually did my undergrad degree at Tufts as well, and kind of the reason I ended up back at Tufts was I really enjoyed the program, and I formed good relationships with many of my professors, most notably, of course, Professor Zenyuk. And I kind of realized that the standard Bachelor's of Science degree really dive as deeply into many topics as I really wanted to, especially when it comes to learning the fundamentals of, say, fluids or heat transfer. Things like Navier-Stokes equations, which in an undergrad course they'll just kind of give you. In a graduate level setting, you really dive into it and derive it, and I found that knowing the fundamentals down to being able to derive the equations yourself means you can take it and apply it to anything. And so that's the real benefit, I think, of graduate level study, is you can take that fundamental knowledge and apply it to a wider range of topics.
Great. Stanley, are you from the Boston area?
Yeah, up in Needham, Massachusetts, which is about half an hour away.
Okay, so I was going to ask you about your transition to area, but can you talk about your transition from being an undergrad to grad in terms of the coursework or the focus that you had beyond the technical detail of the program?
Yeah, undergrad and grad school are fundamentally different. The campus spirit that you have in undergrad isn't so much prevalent in grad school because you're more focused on your specific work. So I'm, on a daily basis, if I'm not in class, I'm in the lab doing research, and my lab happens to be a little bit away from campus. So I would say to prospective students looking at grad programs, think more about what you want to learn and what you want to research, and less about kind of the campus environment, because it's a little bit less important in grad school.
And Sam, do you feel any ties to activities outside of the classroom? Are you involved in like the graduate student council or any activities?
Actually, a trumpet player in the Tufts Orchestra. I found that that's a good way to add a little bit of balance to my life. And that's the one thing that I do kind of outside the lab and outside of engineering to maintain some balance. And I would highly recommend that everyone in a grad program find something, doesn't matter what, some small thing that they can do to balance their life out a little bit, because grad is very intensive, and having something outside of it to balance life out, I feel really helps you with sanity, and it helps you be a better researcher, honestly.
And how many hours a week do you find yourself in the lab?
It varies a lot depending on time of year and where we are in the project cycle. But I would say, and also will depend on how many classes you're taking at a given time, whether it's 2 or 3. A rough estimate would probably be 20 to 25.
Mm-hmm. And how many courses are you currently taking?
I'm taking 2 courses.
Right. Great. Noticing that you are an MS/PhD candidate, could Professor Zenyuk speak to what exactly that means for someone who wants to apply to one of the programs?
So we have an option to apply for graduate school. You can apply to master's program, or master's PhD, or direct PhD program. So for master's PhD program, a student will obtain master's degree on the way to get a PhD degree. So a student has an option to write master's thesis and then continue to the PhD degree and write their PhD thesis. This is also perhaps for the students who not certain in their whether PhDs are fit. So it's a master's thesis is kind of a rehearsal for that final big PhD degree. So generally, it's also master's PhD a program is funded through the research assistantship. That is essentially a student is doing research in the lab, and or a teaching assistantship that is given to the student who work to do teaching assistantships for various courses. So those are the programs we currently have.
And how often do you see students with the MS and not continuing with the PhD? Does it happen often?
It's faculty for 2 years, so for me, it's I have graduated one PhD student, currently I was co-advised, but it's really, I would say it's perhaps maybe 20%. I would say from my experience being a graduate student. So it's a PhD program. It's not fit for every student. PhD program requires really such an intellectual curiosity and drive to solve engineering problems that not every student is as interested in those type of learning, that type of research activities. So so I would say that sometimes it's best for if there's not a good fit, maybe it's better to obtain master's thesis, which is not as in-depth, let's say, individual contribution as PhD thesis would be, and then reassess. And if there's still a good fit, the student can always continue his PhD. If not, there's always options to go and do something in industry or elsewhere.
Stanley, right? You're going to continue on to your PhD?
Most likely, yes.
So can you tell us who your advisors are and how you chose them?
Advisor is Professor Zenyuk, and how I chose her is actually I was working in her lab as an undergraduate student when I was at Tufts, and then I was looking at grad schools. It so happened that she had an opening in her lab for a new student, and I ended up taking it.
So I have a question from our audience. It says, "Hi, Professor, do you have research in battery, such as battery application?"
Great question. So yes, we do. We started being fuel cell scientists, and we expanded into battery research most recently a year ago. We currently have a Department of Energy funded project on solid polymer electrolytes and understanding the interfaces in those batteries that use solid polymer electrolyte instead of aqueous or other types of electrolytes, because they're inherently more stable. And this project we have with Ionic Materials company that is essentially a CEO is Mike Zimmerman, who is the faculty in our department. So we have joint project, and our role is to characterize interfaces with imaging and understand lithium dendrite growth, which is still a problem as it shorted the battery. And another project we currently have is Naval Research Lab. It's looking into battery degradation durability, and that's still on this, but we are sure we'll get some funding for that project too. So we do have an active batteries program, and we are looking for students to join our program who are interested in batteries. Yes.
And again, I want to remind the audience who have maybe joined us that if you do have any questions, please put them in the Q&A chat window, and we will definitely answer them as we go along. Let's transition a little bit here to the program. So, on your screen, the application requirements, the general requirements. But if Professor Zenyuk, could you speak to what exactly you look for in students in your program, and the students that you look for when you're reviewing applications?
Question. So all these listed requirements are necessary. So we look for let's say if the student is applying for Master of Science thesis track or course-based track, the track is more intense and requires perhaps some previous research experience or some kind of industrial internship that the student can show that the student is really motivated to do research and write the thesis. Whereas the non-thesis-based track does not really, we don't look for those previous experiences. Definitely a strong, both students are definitely strong academic background in mechanical engineering or related technical discipline. So those can be engineering background, or that can be science background. In our program, we have several, for example, physics students, several students with chemistry background too. So the one thing we will want to make sure that the mathematics courses they take in are of and receive high grades in those. Non-native English speakers, yes, I'm also encouraged to submit this video supplement. This is something that our application process allowed to do recently within a few years, and the applications that applicants that did submit video, whether discussing their previous projects or some previous research experiences, it really gives us more material to evaluate and more information as to their English proficiency and their more of a research interest. Those type of in the program, obviously GPA from the graduate institution and graduate institutions overall academic reputation, we also take that into consideration.
So, Professor, you mentioned that you have some students in the program and applicants who don't have an engineering undergraduate degree. Do you encourage them to take any courses before they apply, or do you have prerequisites to ensure strong candidates?
This is a good question. Yes, I would say that we would encourage them to take engineering classes, demonstrate their proficiency in engineering subjects. However, if they haven't done that and they would still be interested in applying to our program, those cases are considered kind of outside of our general rubric. We will generally assign the small subcommittee of faculty to discuss the students' preparedness for engineering program, and based on their, let's say, other scores and GPA, and we will look into their transcript to ensure that some of the mathematical courses that are that is really defining our baseline for the engineering program are whether they've been taken, or we would look some other courses that are close to those courses that are missing in the engineering their engineering transcript. So we would consider those students too. We will just use a separate rubric to evaluate them.
So on the recruitment, I often get students who different engineering disciplines from their undergraduate experience. How often do you see applicants who have a different engineering background apply to your program?
Have perhaps between 5 to 10% of, perhaps 5% of students applying from different disciplines. Engineering disciplines and overall different disciplines. Like I'm on the admission committee for our department, and from last year application pool, three applicants with a science major, not engineering major, and perhaps about 3 to 4 applications, not mechanical engineering majors. We get those cases, and specifically students who have interest in research program, for example, here, that looking for specifically, for example, battery research, or like my students, right? They can come from chemical engineering backgrounds, from physics, from chemistry, and so it's quite possible.
And Stan, from a student's perspective, what advice would you give an applicant that is interested in your program?
I'm not sure that I can give much in terms of general advice, because the way a lot of this works is that You're applying to a specific research group, and depends on the needs of that research group as far as their research and who they need to complete it. So, so a friend of mine is applying as a math major, and he applies to a group that does theoretical heat transfer, heavily math-based, and that's a good fit for him, but it might not be a good fit for other groups within the department. So it really depends on the research or program you're trying to do. You want to tailor your application to that specific goal to show that you're ready to do that research or that coursework. There really isn't any kind of general advice I can give other than that.
I think good advice, Stanley. Thank you. So for you, Professor, we have a couple of people asking about research assistantships. It is known that the master's program isn't funded, so can you speak to how someone who is admitted into the program can help fund their program, and are they eligible for research assistantships or teaching assistantships?
So in our program, the priority is given to the PhD students or MS PhD students. So those are, for example, the department decides on the teaching assistantships, and essentially those are the giving by mostly to PhD students. Research assistantships, the faculty, it's actually a student's responsibility to contact various faculty in the department and to inquire whether the faculty has projects for them that the faculty can fund as them as research assistants. And again, mostly PhD students or MS PhD students get funded through that process. However, sometimes faculty have grants that are in short duration, a year or two. Master students can be quite well fit for those type of research projects. And if the student receives a research assistantship from the faculty, so the tuition will be covered, and also the student will receive a stipend. And then essentially from there, the student is expected to do at least 20 hours of research per week. If the teaching assistantship, the student will spend those 20 hours helping faculty to teach 2 courses and grade and do their activities for the class. So so those are available, but the student needs to contact the faculty and see what is the funding situation is of specific faculty they're interested in.
And sir, how many students are approximately how many students are in the program that are doing it part-time and working full-time? Do you have a...
I'm not quite sure, but perhaps our the graduate coordinator, if he's on the phone, Rob White, he can answer the question.
Hi, do you know approximately how many part-time students you have? Oh.
Yeah, at the moment we don't have very many part-time students enrolled, but it comes and goes. So it was probably pretty common to have about 5 to 10 part-time students at some stage in the program at any given time.
Okay, thank you. We do have a question from our audience that says, will I develop my own topics, or will I be expected to work on a professor's ongoing research? That's a very good question.
The student is encouraged to submit to various applications to various fellowships. So there is a National Science Foundation fellowship. There's various Department of Defense fellowships. Once student obtains that fellowship, the student is free to choose any project that the student is interested in working and finding advisors. So the student will be self-funded. The funding for the current research projects that the faculty has come from various agencies, and those funding are essentially already generally come with this project-defined scope of work. So the student will, if, for example, when I hire my PhD students, they are just working on National Science Foundation grants that I received, Department of Energy grants, and so we have specific milestones and tasks to achieve. So the students still operate within those limits, but generally they are very target-driven research. And however, for students to work on their own project, they can generally approach the advisor and pitch their idea and see if they can write together a joint proposal or such a possibility exists too. It's more.
Thank you, and I just wanted to note, for those of you that are joining us today that are interested in human factors, the human factors director of the program made a note to me saying that a background in mechanical engineering per se is not necessarily required for human factors engineering. They are also open to lots of other backgrounds and majors as well. That is good for us to know for those of you interested in human factors MS program. So Professor Zenyuk, can you tell us where, I know you've been here for about 2 years, but can you tell us about where you've seen your graduates go off to? Do they generally go into PhD programs if they did the thesis? And what industry do you see them go to if they decided not to do the thesis?
So question, so I can speak of the students I've had so far. Boston area is reaching various startups and various other industries. So my students generally find jobs, for example, various batteries companies or electrolyzer fuel cell companies that are locally located here in Boston area. Some of the students go off to a PhD program elsewhere. We generally, well, it's for example, the students who have all their degrees from Tufts, we would recommend them to do PhD elsewhere, just to have this experience of various universities. I'm not quite sure where the human factors students get their jobs after finishing their degree, and also some of my students go to the Department of Energy National Laboratories because they're exposed to the research environment there as well. But if James can comment on human factor students, that can be also helpful to know.
Hi, Mr. Trinidad, are you there? Can you speak to where human factors students go once they graduate?
I am here. Can you hear me?
Yeah, we can.
Oh, great. Hi. Hello, everyone. So the human factors students, they tend to kind of come from a variety of backgrounds. So some of them are sort of computer science, human-computer interaction type of background. Some are mechanical engineering. Some are even kind of traditional product design or industrial design. So, and the itself is interdisciplinary in nature. So some of the classes are offered in computer science. Some of them are directly in mechanical engineering. So that mix of different backgrounds and different teacher expertise and lecturers actually leads to a bunch of different potential career paths. So a small number of them will pursue sort of PhD work, but that's really much the exception as opposed to the norm. It's probably only 2% of students actually want to do a PhD in human factors related areas. So most of them go off to the real world, as I like to say, and of that, I get about probably 80% of them are interested in and go into things related to sort of digital design, user interface, user experience, usability testing, sort of everything. A lot of it is, of course, nowadays web-based or app-based. That's where many of them go. And then there's about maybe 20% of them who are interested in physical product design, and so they go off to, one of them came back and just gave a talk. She is now at IDEO doing product design. Others have gone off to other sort of design agencies. So it tends to be 80% go into digital, human factors engineering, engineering psychology, and 20% go into kind of physical, product design, product testing, things like that.
Thank you, Professor.
Sure.
We do have a question from our audience. It's from, it says, how quickly do MS students have to identify advisors and a research topic?
I would say that the master's student should spend at least 1 year in the research laboratory. The thesis track, if the thesis track is 2 years, so the second year, the student should be very actively involved in the research, in doing the research. So first year, when the student should identify the research lab. So it can be second semester, it can be early first semester. We understand that the student needs some time to perhaps try different labs to see which one fits the student interest the best. I would say that the best, it would be second semester of the first year when the student identifies the advisor in the research lab.
So, Stanley, can you let us what would say to someone if they're trying to decide between coming to Tufts and doing a degree in mechanical engineering and going to another institution? What would you tell them to convince them to enroll it if they were admitted?
I would, when choosing a program, especially if you want to do research, is think about exactly what the research you want to do is, and find the program that most mirrors the research you want to do. And as far as Tufts goes, I've had a chance between my undergrad and graduate time here. I've had the chance to meet and work with in some capacity, usually just through coursework, but sometimes through collaborations with other labs, most of the faculty in the department, and they're doing a lot of really interesting things. Every one of the faculty members has an interesting story to tell, some type of research that's pushing the boundaries of their respective fields. So I think that's really Tufts' strong suit.
And Professor, what would be your last pitch for someone that is contemplating applying to the MS in mechanical engineering? What would you do to say to them to encourage them to apply?
I'll say that, okay, I've been here for 2 years, and Tufts, so we are really student-oriented faculty. We are very much interested in student learning, in students doing research. The class size is quite small. You get to interact with faculty here at Tufts. We have a lot of classes that have lab components, so you learn hands-on techniques, and have the shop is quite well functioning. Clean room, you have the classes that are taught in the clean room for those who are interested in microelectronic devices and such. So I would tell you that we have an excellent master's program, and both in non-thesis track and thesis track with various faculty. So please apply, and we'll be happy to talk to you anytime you contact us if you have any other questions.
Great. We are fortunate to have Professor Interrogator on the phone as well. Can you tell us, Professor, to convince someone to apply to the Human Factors MS program?
Could do that. So I'm also actually new to Tufts. I've only been here 1 year, and I love it. It's a fantastic place. It does have a kind of a small school feel, so I think the students don't tend to feel that they're just caught in a machine and lost in this massive university complex. You know, it's actually an incredibly kind of small, tight-knit department in both mechanical engineering broadly and human factors in particular is actually, really tight-knit. We get there every Monday night, the faculty to go dinner and chat and stuff. So it's a kind of cozy place to be a student. That's my sense. It also has a fantastic alumni network in terms of kind of networks and connections. Again, broad mechanical engineering, but also specifically for human factors. In fact, for the human factors engineering undergraduates, I think there is that over the last 5 years, it's something like 98% of our students graduating seniors have already had a job at least 6 months before they graduated. So very highly in demand at the undergraduate level, and at the master's level, it's the same thing. The master's students find jobs, usually multiple jobs, before they have even finished the program. It's an incredibly well-respected program. It's probably the most, I don't know if it's the most, but it's in the top, 2 or 3 most respected programs in the country for human factors engineering in particular. So great kind of pathway to launch a career and get into lots of different possible directions. And again, it's also a fairly small program. So, some human factors engineering programs, at the graduate level, they may have 20 or 30 students. They're smaller. We only have 15, 20 students. Even incoming classes tend to be only about maybe 10 students get accepted each year. But again, those students get to form a pretty strong cohort and get to be involved in lots of different research. The one thing I wanted to mention about the human factors program is that most of our professors actually are professors of the practice, or they are professors who have day jobs, so to speak. So they're not full-time academics. In fact, I guess I'm the only full-time day job is at Tufts. Most of them actually have jobs at places like MIT, Lincoln Labs, or at various kind of design agencies in the area. It's great because they get to bring in their own knowledge and expertise to the classes that they're doing, and students get to see live examples of things that are actually happening out there in the real world. That's a real benefit, I think. One final thing I want to mention about that is that many of the classes taught by them, especially at the graduate level, tend to be in evenings, and that's done sort of on purpose so that master's students can, for instance, have interns during the day, things like that. So it's a pretty flexible program in that regard.
I still have you on the phone, Professor Alligator. We have a question, and I'll throw this to you afterwards, Professor Zenyuk. What kind of student thrives in the human factors program? And also, there are some kind of restrictions on access to facilities available for research?
Well, the kind of student that thrives, the program is pretty demanding, and it does require students to take, a good mix of both creative classes and also sort of highly technical classes. So it's sort of kind of comfortable working at the intersection of kind of art and technology, or design and mechanical engineering, or computer science and mechanical engineering. Those are the students I think who really thrive here. People who like to kind of work at the intersections of things, and who like to think about sort of design in the broadest terms, from the use side of things to the technical to the mechanical. So those are the students who thrive. In terms of restrictions on access to facilities, it depends. I mean, in general, I would say, no, if you're part of a research project, or if you're part of a professor's lab group, there's within, of course, safety restrictions. So you have to be trained up to use certain machines and all that kind of stuff, and we have some pretty expensive machinery. But if a student has a project that is meant to involve a piece of equipment, it's not in general, the demand is not too high, especially for time, etc. Especially in human factors. I think some of the more specialized equipment, it might be a little harder both to get certified or to get approved to use it, also to find time on it. But in general, there's not heavy restrictions now.
Professor Zenyuk, can you are you able to add anything to what Professor Intrigator just mentioned in terms of how students thrive in mechanical engineering?
Professor Intrigator summarized it quite well. We, as I mentioned before, we do have a very well-functioning machine shop, and the students can their projects and machine them and work on them, and we have various additive manufacturing and micro mills devices available there for their projects. And so yes, highly motivated students. The program is quite intense, and there's a dedication from a student's point of view.
Slowly winding down on time. So again, if anyone in our audience has any more questions, please type them into the Q&A box, and we'll get to them. But Professor, can you speak to our new science and engineering complex? I know it was just dedicated, and it has some great lab space. So
this is a science and engineering complex complex been opened just a few months ago, and mechanical engineering department is hosted officially there. So we have all our faculty and administrative offices in that building. Building is also equipped with various state-of-the-art classrooms that encourage student-centered learning experiences. So, for example, various digital TVs and various electronic equipment, and also we have several classrooms that are equipped such as labs. Those are used by chemical engineers and biomedical engineering students, not as much of medical engineering students. But then Sen being a teaching assistant for one such a course taught in this new classroom, could you perhaps Sen can comment more on that?
The mechanical engineering department has always had its own computer lab for students to use because a lot of our courses and work relies on a great number of very expensive pieces of software that the school provides for us in the form of this computer lab. And the new version of this computer lab was just opened in the new building, and has come equipped with some new features, including the entire 360 degrees of walls. Every wall in the room is a whiteboard. So it's intended to foster collaboration, and kind of any time an idea hits you, you can just write it down on the wall.
Fantastic. We are so excited to have that brand new science and engineering complex. It adds to our ranking as a Tier 1 research university, so we were very fortunate for it to come online this year and for our Department of Mechanical Engineering to be housed in there, as well as other departments for interdisciplinary work. I do have a question as I mentioned we are winding down, but it does say, Professor, could you talk a little bit more about the optional video as part of the online application? What kind of video and how long should it be? We can always explain, Professor Zenyuk, when you're reviewing applications, what type of video are you looking for, even though optional?
Right. So I would recommend that applicants do some of their videos. This video is not going to hurt their chances; it's going to only help their chances. So clearly, the videos range in time anywhere from 5 to 15 minutes. Sometimes they're longer, but generally the student is presenting some kind of project they did in one of the classes or as research experience. So it can be a student filmed in the lab, showing us the equipment they used, how they connected things. So it can be some theoretical work. One of the applicants, for example, was applying for the superconductivity lab here at Tufts, and she essentially explained us how superconductivity works, just writing on paper and telling us more of the theoretical background. So it can be either. So the goals are just to understand the students' research interest, but also evaluate their English proficiency.
Great, Professor. So wraps up our virtual information session for the day. I'd love to say thank you to Professor Zenyuk, Professor Interrogator, and Professor White for joining us today, but most importantly, Professor Zenyuk for being our lead faculty member on the session. And of course, thank you to our current student, Stanley, for joining us and giving us some insight into his experience both at Tufts and in the Mechanical Engineering Department. Please email us directly in the Office of Graduate Admissions if you have any personal questions about applying. If you'd like to be in touch with a professor, we are here for you. Our information is on the current slide. Be sure to follow us on social media platforms, Twitter and Instagram. The School of Engineering also has social media accounts. Again, if you have any questions, do not hesitate to contact us. And thank you all for joining us today.
Thank you so much.